So till now we have discussed the fact that magnetic effects of current do exist. What was that? When current is flowing through a conductor, magnetic field is set up across the conductor, due to which the magnetic needle's orientation, the direction of magnetic compass changes, which shows us that magnetic field exists. So instead of magnetic effect of current here, now we are going to discuss about magnetic field of current. To see that, a very simplified experiment was done to see what and how is the magnetic field of current. We took a straight current carrying wire and we passed it through a cardboard, okay, wooden cardboard like this, and the circuit was completed. Then suppose these are cells, we have a switch, we have just completed the circuit. So current is flowing in this direction. So what we did was, when current is flowing through this wire which is passing through this cardboard, we placed again the magnetic compass at several various positions, here, 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 here and here, and we saw that this compass was showing directions like this. If you place it all around the corner, the direction was this. So if you place it all around the circle, you will get an entire circular path. So this proves that magnetic field due to current carrying conductor is in circular loops. This is how magnetic field of a wire exists. So we have done this thing, and we have also proved it, that magnetic field due to current carrying conductor exists, and it exists in circular loops. Now if we have to do what? If we have to find or simplify a rule to obtain the direction of magnetic field and to represent it in somehow, what we gonna do is we explain it or we elaborate by a rule called right hand thumb rule. What is right hand thumb rule? It states that you place the thumb of your right hand, you have to keep it in mind that you have to use right hand only. You place the thumb of your right hand in the direction of flow of current, that means like this. Curling of fingers, so this curling of fingers, the circular turn which fingers are taking, it is going to show me the direction of magnetic field. So that means if current is going in this direction, so right hand in this way, curling of fingers is like this. So magnetic lines of force, they are what? They are entering this surface, this part of the region, and they are exiting from this part of the region. So the lines are something like this. They are entering this part, okay, entering this part, and they are coming out, emerging from this region. So can there be any more simplified way in which we can explain that lights, all these magnetic field lines are coming out of the region and going inside the region? Yes, there is. What we do, we simplify it with dots and cross. So we use dots at the points where magnetic lines of force are coming out from, and we use cross at the point where magnetic lines of force are going inside. Why do we do so? See, right hand thumb rule, direction of current is in this. So according to right hand thumb rule, fingers are going inside in this region and they're coming out from this region. So when you see above the arrow which you fire from above, the arrow, if the arrow is coming towards you, you will see only the circular portion which is like a dot. But if you will see an arrow which is going away from you, farther from you, you will see the cross behind it, right? So when something is entering, it's like an arrow entering the surface, so you will be able to see cross, and when it is emerging out, you will be able to see the dots. So that is why magnetic field is represented in terms of dots and cross. Now one more thing, I stated in right hand thumb rule that, what does this state? That if we place the thumb of our right hand in the direction of flow of current, then curling of fingers gives the direction of magnetic field. The converse is absolutely true as well. So what did I just say? Thumb and curling of fingers. So if thumb represents flow of current or direction of flow of current, curling of fingers is representing magnetic field. So my point is, the converse of this theorem is true as well. That means if curling of finger represents current, then thumb will be representing magnetic field. How we can see that? Consider a circular loop like this in which current is flowing in this direction. So I'm going to use the cross thing, that is curling of fingers in the direction of current. Curling of fingers in the direction of current. That means the thumb is going to show me the direction of magnetic field. That means magnetic lines of force are coming out from this region. So there will be all dots, right? And if the loop is having current in this direction, so curling of fingers like this, magnetic field is going inside. So I'll be representing it with all cross. So now you see the magnetic field in a circular wire can exist in only two portions. If the current is anti-clockwise, the lines are emerging out. If current is in clockwise direction, the lines are going in. Now same thing happened in case of a bar magnet. Suppose I place a bar magnet here, okay? This is my bar magnet, North Pole and South Pole. Magnetic lines of force are emerging out of the North Pole and they are entering South Pole, right? This is how it is going. So if you just see the front side of the North Pole, suppose this is the thing, so lines are coming out, and the back side of South Pole, it will be something like this. That means this circular loop, if I place it in vertical plane, it is also going to behave like a magnet. How? Because at from one side the lines are coming out, whereas after covering some loops they are going inside the second region. So this current carrying loop, which is circular in nature, also behaves like a bar magnet according to properties of magnetic field.